Welcome to Sunday. So the last video I was having a little issue with the pinning on Dotstars, but I figured it all out what was going on. I forgot about this. If you look on the back side of the Dotstar, and can I zoom in even more? There. If you look, see these DN and CN right here, and they have little tiny joiners on them. So when you use this in a hat, like you stick it on top of a feather like this, right? You're stuck with the CN DN control of the thing. Now on a atmel feather, this is the feather M4. If we power this up, and I'll just turn the brightness down a little bit, you can see it changes okay. It's like reasonably fast. It's not the fastest going, but through the CN and DN pins is doing reasonably well. Okay. Now, change this out, and we put it on an RP2040 feather. Yep. Like so. And we plug this one in. You can see it's really slow compared to the atmel one, but only for the CN DN pins. Now if we go and take this off like so, and I happen to have, I'm just going to pin this and we need orange yellow, so we need SCK and MSO, which is right there. So now what I've done is, instead of having the hat on, I have it beside it, and these two wires right here, okay, which corresponds to the same CN and DN on here, is now wired to the hardware SPI. If we plug this in, we have to change the line of code, of course. So first we need to mount our CircuitPy drive like so, and then open the workspace. So now I will change this here and we'll go back to the main screen and I'll dim it. You can now see, oops, the cables weren't in so much in the way. It's changing very fast. Yeah, my breadboard's a bit sensitive to wire movement, so. But you can see it going really, really fast. Fastest of the two. Now I'm pretty sure on the RP24 the D13 and D11 is software SPI, and the SCK MOSI is hardware SPI. So if you want to make this hat work like this standalone, like that, you are going to have to break these joints here, and then solder a wire from here to here, and here to here. DIN corresponds to MOSI, CN corresponds to clock. So you have to jumper these pads like so. And then when you plug it in here with this code, it should run just as fast as this. Now, one thing, I'm not kind of happy with this because this means it's almost like a permanent change. What if you want to flip back? And you have to undo the wires, and then do the wires, then undo the wires. It's like, not good. Now there is a CNDN up here also. Right there. You can see it. So yeah, the camera doesn't do this justice. This is actually very colorful. But that is the issue with that. Now, I also have, that's Dotstar. I also have, of course, NeoPixel. But this one's a lot easier to deal with. I don't have code set up on here. I do on this pink feather over here. The one I've been using for driving some other stuff, which I can now show you too. So, and this guy here is also Dotstar. I just added the power and clock and CNDN wires, blah blah, and it works just fine. Like if I hook it up to here, just like I did this one, change the pixel count to 64 from 72, no problem. If nice and bright. So that is Dotstar. Now let's close off our workspace here. Close workspace. There we go. And safely remove this. We don't want to corrupt the file system. And we'll put this one aside. Now I was messing around with, and I'm going to zoom way back out. These guys. So I added a DC barrel jack. And on my bench over here I have a variable power supply. So we'll put that in there. And then we have here a ground and a clock, or data control line. So green, purple, and I happen to have it on 5 on this guy, like so. And then we need a ground, ground right there, so like that on the pinky. Then we plug the pinky in, and we turn the power supply on. Here we go. Voila. And this is just using the Adafruit NeoPixel code. So if we open the workspace up, File, Open Workspace. That's all it is, this. Except we're not 512 pixels. We'd be messing around, so 50. There's a bit of a flicker on here. There we go. Maybe we've added some voltage to this. There we go. So these are fully addressable pixels. They are what they call 2811s, something like that. In a sec. Did I have this up? Yeah, WS2811s. These are what WS2811s. Yeah. So I have 2 batches of them. I have another one here. So in theory, I can go like this and plug dish into dish. Let's see. Like so. Change this to 100 pixels. There you go. Ta-da. All driven off the pink feather. Because, hey, you know, pink feathers, they drive LEDs the best. They spin those electrons just right. Now, you can, of course, do this off with the Arduino, too. Arduino. So that's how I was messing around with that. Then I have another one. Let's just take this off. You don't need this. And by the way, getting these clips off is hard. Here we go. So I had here, I showed this off before. The color wheel, but this time I finished all the soldering on the back. So this guy here was, I think 241. And so we need, brown is ground, I believe. Yeah, brown is ground, red is power. So ground, power, and then I rigged it to line 5, so we put it on line 5. Oh, sorry, wrong one. I put it on 3.3 volts. You need to use the USB power on here. That didn't work. What did I do to it? Well, it was working just a little while ago. Did I get the pin 5 right? Nope, I'm on pin 6. There we go. There we go. Whee! But you get the idea. It's very hypnotic. But so that was the color wheel. I put it together. Put it in here. So let's close this workspace off again. File, close workspace. That had Dotstar on it. So on this, I think data pin was this one, which corresponds, that is 1, 2, 3, 4 in. So that would be 1, 2, 3, 4 in. 6. So this is 6. Now I don't know what'll happen when I plug this in, actually, technically. I have Dotstars stuff running, so code has to change. Yeah. Okay, let's open the workspace. CircuitPy, Feather, open. Yeah, so I have the Dotstar code. I wonder if code 1 is... No, that's that one. I think I need an update in here. Nope. Code 1 means I don't have Adafruit display, yada yada, and Adafruit display text. That could be fixed. That one's already installed. Well, they're both installed, so what are you complaining about? Oh, I know what it is. Duh. What are we, 1219? 1219. And this is 0821. 1219. 1219, Control S. There we go, code fixed. Now I don't know this. No, this won't do it correctly. This is for something else. So we need the NeoPixel code, and I have a copy of the code. Does the pink have it? No. This has it. No. Too many boards. Where did I put the code? Oh, yeah, the pink does have it. We need to borrow the pink for a second. We need code off it. Let's copy that code, and over here, let's just rename this to code 2. And come back over here to this and go to CircuitPy, this one, paste one file. Okay. Code. Oh, sorry, pin 6. And I don't think we're 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 16, 32 pixels. 32. I'm sure board D6. Okay. Oh, do we have the NeoPixel library in here? No, we don't. Okay, that's why. Here we go. Now I don't know why the first NeoPixel is so bright. What if it's shared between it and the one that's on the feather? Because there's a NeoPixel on the feather too. So if we turn the brightness up here, so we look at the desktop, you can see right here there's a NeoPixel on this feather, for example. But there goes standard NeoPixel matrix. A little different than the Dotstar, bigger thing. $32. Does it start at 0 and go to 32, or 0 to 31 and 1 to 32? I'm not sure. Nope. It is 32. There we go. Just don't know why that one is full on. But there we go. That's that. Okay, let's close this workspace off. I tossed them somewhere. I also had those fairy lights, but it's basically exactly the same. Where did I put those fairy lights actually? Right here. So fairy lights. So let us safely remove this one. I think it's this guy here. No, that's feather pink. It's this one. Safely remove. Okay. This guy here. So one thing you have to be careful on these particular ones, it's not marked very well, but this guy right here is red. So that's power. So 5 volts. White is ground. And this is 5. There you go. So we open this one up, file, open workspace, the pink feather. There's 20 LEDs on here, 20 NeoPixels. So not 241, so we need to change that to 20. And did I have us on D5 or D6? No, I have it on D5. So now to make this work, I think, Control S. There we go. 3.3 volts on this. Works just fine. But there you go. fairy thing. Here, let's turn the brightness down here. Whoops. I pulled the pin out. There we go. Oh, I see what's happening. My DuPont connector is coming out of its shell. There we go. And you can change it to the next one. But with any of these guys, you got to watch out. These chains like this, they have a current limitation, so you have to do a bit of power calculation to figure out. Oh, I don't need this on anymore. Otherwise, the power off the controller won't be enough. Like, I mean, the USB is only 500 milliamps, so. But there we go. That's the fairy lights. So if you have a mini Christmas tree, like a really, really small one, you could use that. So, whoops. But there's an explanation for all the matrices I do actually have. Of course, I have other ones. I mean, bigger ones like for example, this guy here. I have this in a bigger, longer strip. I won't get it down. But I can go like this with this guy here. And then plug it into here. Red being power. In this case, yeah, 5 volts is needed. So, USB 5 volts. Data on 5. And ground. There we go. Now, since we only have that many LED, we need to change the number, and I believe this was 256. There you go. Now, the slowness is right in the code here. If you take this weight out here and then do it, there you go. See, much faster. But remember I said about the snake? Back, forth, back, forth, back, forth. You can see it exactly happening in here. And this is flexible. See? In theory, you could put it around a beer mug. Oh. Yeah, there we go. But that's that one. I have a smaller one and I have a bigger strip. I have another 256, but it's in a strip. And then I have some 64s there. And yes, you can chain them all together. And in theory, I could chain these guys to that one because it's the same wiring, same stuff. You just have to watch the power, and that's why you need a church like one of these guys. See, you do. This one's up to 12 volts. I think I have another one from Adafruit that's I think goes up to 24 volts. But they're handy little variable power supplies. I have another one over there, but I can't reach it properly. This bench is not made to do that. So I'm going to cut it here. So I hope you had fun with looking at LEDs and getting your eyes blinded. What else am I going to do? So much time, so little to do. I think next I'll put this clock together. Clocks are pretty easy to put together. But I'll let you go.